What then of manned space exploration? The government recently announced plans to return to the moon by 2024. The successful conclusion of that mission will result in the infrequent visitation of the moon by a small number of government scientists and pilots. It will leave us no further along in the general expansion of humanity into space than we were 50 years ago. Something fundamental has to change if we are to see common access to space in our lifetime. What I'm going to show you next are a couple of controversial ideas, and I hope you'll bear with me and have some faith that there's credibility behind what we're going to say here. There are three underpinnings of working in space privately. One of them is the requirement for economical Earth-to-space transport. The Burt Rutans and the Richard Bransons of this world have got this in their sights, and I salute them. Go, go, go. The next thing we need are places to stay on orbit. Orbital hotels to start with, but workshops for the rest of us later on. The final missing piece, the real paradigm buster, is this: a gas station on orbit. It's not going to look like that. If it existed, it would change all future spacecraft design and space mission planning. Now, to give you a chance to understand why there is power in that statement, I've got to give you the basics of Space 101. And the first thing is, everything you do in space, you pay by the kilogram. Anybody drink one of these here this week? You'd pay $10,000 for that in orbit. That's more than you pay for it here for it at TED if Google dropped their sponsorship. The second is more than 90% of the weight of a vehicle is in propellant. Thus, every time you want to do anything in space, you are literally blowing away enormous sums of money every time you hit the accelerator. Not even the guys at Tesla can fight that physics. So, what if you could get your gas at 1/10 the price? There's a place where you can. In fact, you can get it better. You can get it at 14 times lower if you can find propellant on the moon. There was a little-known mission that was launched by the Pentagon 13 years ago now called Clementine. And the most amazing thing that came out of that mission was a strong hydrogen signature at Shackleton Crater on the south pole of the moon. That signal was so strong it could only have been produced by 10 trillion tons of water buried in the sediment, collected over millions and billions of years by the impact of asteroids and comet material. If we're going to get that and make that gas station possible, we have to figure out ways to move large volumes of payload through space. We can't do that right now. The way you normally build a system right now is you have a tube stack that has to be launched from the ground and resist all kinds of aerodynamic forces. We have to beat that. We can do it because in space there are no aerodynamics. We can go and use inflatable systems for almost everything. This is an idea that, again, came out of Livermore back in 1989 with Dr. Lowell Wood's group. And we can extend that now to just about everything. Bob Bigelow currently has a test article in the orbit. We can go much further. We can build space tugs, orbiting platforms for holding cryogens and water. There's another thing. When you're coming back from the moon, you have to deal with orbital mechanics. It says you're moving 10,000 feet per second faster than you really want to be to get back to your gas station. You got two choices. You can burn rocket fuel to get there, or you can do something really incredible. You can dive into the stratosphere and precisely dissipate that velocity and come back out to the space station. It has never been done, it's risky, and it's going to be one hell of a ride. Better than Disney. The traditional approach to space exploration has been that you carry all the fuel you need to get everybody back in case of an emergency. If you try to do that for the moon, you're going to burn $1 billion in fuel alone sending a crew out there. But if you send a mining team there without the return propellant first. Did any of you guys hear the story of Cortez? This is not like that. I'm much more like Scotty. I like this equipment, you know, and I really value it. So we're not going to burn the gear. But if you were truly bold, you could get it there, manufacture it, and it would be the most dramatic demonstration that you could do something worthwhile off this planet that has ever been done. There's a myth that you can't do anything in space for less than $1 trillion and 20 years. That's not true. in 7 years, we could pull off an industrial mission to Shackleton and demonstrate that you could provide commercial reality out of this in low Earth orbit. We're living in one of the most exciting times in history. We're at a magical confluence where private wealth and imagination are driving the demand for access to space. The orbital refueling stations I've just described could create an entirely new industry and provide the final key for opening space to the general exploration. To bust the paradigm, a radically different approach is needed. We can do it by jump-starting with an industrial Lewis and Clark expedition to Shackleton Crater to mine the moon for resources and demonstrate they can form the basis for a profitable business on orbit. Talk about space always seems to be hung on ambiguities of purpose and timing. I would like to close here by putting a stake in the sand at TED. I intend to lead that expedition. It can be done in 7 years with the right backing. Those who join me in making it happen will become a part of history and join other bold individuals from time past who, had they been here today, would have heartily approved. There was once a time when people did bold things to open the frontier. We have collectively forgotten that lesson. Now we are at a time when boldness is required to move forward. 100 years after Sir Ernest Shackleton wrote these words, I intend to plant an industrial flag on the moon and complete the final piece that will open the space frontier in our time for all of us. Thank you.